Hello, this is question 72 on stoichiometry, and you're going to have to pay a little more attention to this one because it may be a little tricky. The combustion of 90 grams of propene, that's C3H6, produces 81% yield. What is the actual amount of CO2 produced? Now, we are going to assume here that this 81% yield is 81% yield of CO2. Okay, so they've given us the percent yield and we're asked to get the actual yield. Now, we should know that the percent yield is equal to the actual yield divided by the theoretical yield multiplied by 100%. That's how you calculate percent yield. Now, we're asked to get what the actual amount of CO2 is. So that is like asking you, what is the actual yield? So we know the percent yield, that's 81. So we really need to know what the theoretical yield is so that we can plug it in here and solve this question. So that's it. So we have to go ahead and calculate what the theoretical yield of CO2 will be if 90 grams of propene is combusted. Does this make sense to you? All right, so let's go ahead and do that. By theoretical yield, it just means what amount of CO2 should be produced by calculation. Okay, that's what theoretical yield means. There's some theory there, so it's just calculation. Right, the first thing you want to do before calculating the amount of CO2 that should be produced here is to make sure that this equation is balanced. So I would write it out here again. C3H6 plus O2 is producing CO2 and H2O for us. So if you want to balance this equation or any other combustion equation, this is how you do it. The first thing you need to balance here is the carbon. So carbon on the left-hand side is 3. Therefore, you'd have to make carbon on the right-hand side 3. By doing that, that's the first thing you balance. The second thing you balance is the hydrogen. So the hydrogen on the left-hand side is 6. On the right-hand side is 2. So I have to place a 3 here so that it will also be 6. And then I'll balance the oxygen last. That's the third thing that you have to balance here. So there are just 3 things. If you follow this step in this order to make life easy. So oxygen now. How many oxygen do we have here? 2. And then how many do we have on the product side? 3 times 2 is 6 plus 3. This is 3. 3 times 1. So that's 3. So we have 9 on the right-hand side in total. And on the left-hand side, we have 2. So I have to multiply this by 9 over 2. So that 9 over 2 multiplied by the 2 down here would give you 9 on the left-hand side as well. So that's how we do it. So you could choose to balance it like this or multiply through by 2 if you want to get rid of the fraction. So once this is balanced, I can now compare the number of moles of propene with number of moles of CO2. Okay, because it's balanced now. So yes, I'll just compare that. And then what can I see there? 1 mole of propene gives me 3 moles of CO2, right? So if I'm dealing with 90 grams, which I can actually convert to moles, then I should also know the number of moles of CO2 that should be produced. All right? And then I'll convert that moles to mass at the end. So that's how I'll get my theoretical yield. So let's do the number of moles of propene that was, introduced here. Number of moles of propene is mass divided by molar mass of propene, and that's 90 grams divided by, what's the molar mass of propene? That will be 3 multiplied by carbon is 12, and then 6 multiplied by 1, Where am I getting these numbers 12 and 1 from? It's basically from the periodic table. 12 approximately, and then 1. These are the relative atomic masses of carbon and hydrogen. I'm just approximating the values here. You should check the periodic table. You actually see it in maybe 2 decimal places or even 3 or 4. All right, so let's work that out. What's the number of moles of my protein? That should be, when you solve all this, right? The denominator there should give you around 42. So that's 90 divided by 42, and that's 2.1428. So 2.1428, that is the moles of C3H6. So by proportion, since 1 mole of this produces 3 moles of CO2, it just means that if I have this number of moles of propane, then the number of moles of CO2 that should be generated will be multiplied by 3. So number of moles of CO2 will then be this number, 2.1428, multiplied by 3. See that? And that would give us 6.428 moles. If any part of this explanation is not clear to you, let me know in the comments so that we'll try and explain it to you. So yeah, but this is where we've gotten to so far, the number of moles of CO2. Now, can we convert that to mass? First off, the molar mass of CO2 would be 12 plus 2 multiplied by 16. That should give you 44 grams per mole. And if you want to get the mass of CO2 that will be generated, it's just going to be number of moles times molar mass. So that's 6.428, this number of moles here, multiplied by this molar mass that we just calculated. So what does that give us when we multiply? About 282.85 grams of CO2. You see this stuff I've calculated here now, 282.85. That stands as the amount of CO2 that will be produced by calculation, meaning that this is the theoretical yield. Does that make sense? So if that's the theoretical yield and we know the percent yield, it means that we're almost done with this question, right? So let's just plug that in. Actual percent yield, which is 81%, I'm going to write that like this. 81% is equal to the actual yield, which is what we don't know, divided by the theoretical yield, which is 282.85. So this is my equation. And then I'll just solve for the actual yield by cross multiplying and dividing both sides by 100. All right. So if you're asking that what happened to this 100 here? Well, if you look at it, 100% is 100 divided by 100, which is 1. So I didn't need to write it. Besides, I have already accounted for the 100 by writing it this way, my percent, as 81 divided by 100. So that's what the 100 is actually. So I can solve that, and when I do my calculation, the actual yield is going to be equal to 229.114 grams. Okay, that's what we're going to have at the end of the day, and that is the answer to this question. So let me know if this was helpful for you by leaving a like, and I'll see you on 73.